Good morning. Well, it's morning for me. 7.5 is our lesson today. We don't often talk about mathematicians, and we should. This is Carl Friedrich Gauss. And about 200 years ago, a teacher in Germany wanted to keep his students busy for a while. So he asked them to add up all the numbers from 1 to 100. So that's 1 plus 2 plus 3 plus 4 plus 5. So the picture you're seeing is not the man, it's the student. It's 10-year-old Carl Friedrich Gauss. He got the correct answer within a few moments while his classmates still struggled with the problem for several hours and got it wrong. So, and the story is that because he solved it so quickly and the teacher was hoping to keep them busy for a while, the teacher got very frustrated and actually sent poor Carl home. So here's what Carl did. What Gauss did. First, we're going to use this notation here, S100. You're used to a T being here. That would mean the 100th term. S100 means the sum of all of the numbers from 1 to 100. So it's the sum of all of them for the 1 to 100th term. So the first term is a 1, then a 2, right? So here are 100 terms with the dots in the middle represent all numbers that I skipped. So he wrote it out kind of once, just partly like I did there. Then he wrote it out again, but this time he wrote it in the opposite order. So it's still the sum of 100, but he wrote it out again, but this time he wrote it in the opposite order. Then the next part that he did was he thought, I'm going to add these two sums together. So when you have the sum of 100, you add these two variables, parameters, and you get 2 S100. And then he added down 1 plus 100, 2 plus 99, 3 and 98. So he got 101 all the time. So how many 101s are there? So think about that for a second. So what he's got is 2 sums of 100. And that's equal to how many 101s are there? There's 100 of them. So 100 of them. It's got 100 times 101. So this is what made it really quick for him to do it this way. But then we've got to isolate this sum of 100 because his teacher only asked him to add them up once, not twice. So he divides everything by 2. Sum of 100 terms is going to be 1/2 times 100 times 101, which is 5,050. And that's how he did it. Gauss's method was used to develop the formula for an arithmetic series. Recall that a sequence is a list of numbers. That's what we've done previously, sequences. Now we're talking about series. A series is the sum of all of those. We're going to put Gauss's strategy into a formula. So we're starting with the sum of n terms, right? So this means that when that's our unknown, we don't know how many terms we have in general. So he took his first term, in this case he had a 1, and then underneath that he added 100. So he took his first term, added on his last term, then he multiplied that by the number that he had. He had 100 of them, right? So the first term, so like he got 1 plus 100 multiplied by how many he had, and then he divided by 2 because he originally had a 2 here. So that seems like such a straightforward thing, but he figured that out, and that was put into a very straightforward formula. So S at n equals to the first term we already know is a. We've talked about that before. The last term is t at n, right? That's what the last term is. For number of terms, we're going to just use the n and then divide by 2. So this is a formula. So you need to memorize this formula. This is a formula for the sum of an arithmetic series. So it has to be arithmetic. And if you think back to the beginning of the unit from 7.1, we had this formula. Remember this formula here? This one is for the general term formula. And we can use the general term formula in here in place of this t at n in the sum formula too. So those two can be swapped out. So if you happen to know the last term, that's great, you just put it in there. But if you don't know the last term, but you know some other information, then you can use this formula in its place there. So I'm just going to show you what that looks like when we sub in the t to n formula in for n. Clean all that up, distribute, and it looks like this. And you don't have to memorize this. You have to memorize this one here. And we can get to this formula here just by subbing in if we need to. And this is a little more messy to memorize. This one's easier, so just memorize this one here. But you could use either, but we're just going to use the main one for our lesson. We usually use the first formula. It's easy to memorize and to sub into. Example 1. So you've printed off your sheet, hopefully, or you've copied out the examples. We're going to find the sum of the first 100 terms of this series. So notice I don't know the 100th term. It's not here. I don't know what it is. So I don't know my final term. Here's the formula. That's the first thing you're going to write down. First thing, write down a formula. We know, what we do know is that n is 100. That's first 100 terms. So we're going to sub that in. It's great to know n. N is here a lot. Look at n is there, n is there, and n is there. If you know n, it's really makes things faster. So we're putting our 100 in for all of the n's. The other thing we know is our first value, a is 1. Subbing that in there. Okay. We're left still with two unknowns. This is an unknown, and term 100, I don't know that either. And we can't solve one equation with two unknowns, so there must be something else we can use. So think about this for a second. Think about what I said on the previous slide about what we could do here. We're going to sub in this formula. We're going to try to use this formula here in this place because we're stuck here. We know n, a, and d. Right, so d, we hadn't talked about that yet. I put it in blue. D is the common difference, so we're adding 3 each time, adding 3, so our common difference is a 3. So we can simplify this, all of this, and we get 298. So what do we do with the 298? We can finish the sum formula now. There it is. There's the sum formula. That's where we got stuck, so we're going back to that spot. But we're putting in 298 for term 100 because we got that down here. Term 100 is 298. And doing a little bit of math, we get, therefore, the sum of the first 100 terms is 14,950. When you do any of these questions in this unit, it's really important to highlight your final answer because as you can see here, we just kind of moved back and forth a bit, right? We got stuck here. We have to do this kind of on this side, and then we went back up to here again. So if I'm looking at your math and I see this is your final line, see the way mine is? This is at the bottom. If I was marking this, it'd be like, is this the answer? Because this is at the very bottom. It's not the answer. So make sure your answer has a box around it, always in this unit, so that it's easy for me to see what your answer is. Example 2. I think this is on the back of your sheet. Find the sum of this series. So is it arithmetic? Yes, it is. So we know we can use the sum formula. Remember that Tn is the last number or the general term formula. So Tn means two things. In this case, we're going to sub in the last number for Tn. We don't know how many there are. Is negative 40 the 50th term? I don't know. But I know it's the last term, so it's going to go in for Tn. Let's sub that in. Negative 40 goes for Tn. Simplify what we can, and we get the sum of n terms is negative 10n. So we don't know n, and we always get stuck when we don't know n. We have two unknowns. We have this is an unknown, and this is an unknown here, so we're going to have to find n. You guessed it, our very important formula from 7.1. This is the general term formula. It's also will also give the last term. So we know, remember, this was our last term was negative 40. I don't know what n is. I'm trying to figure that out, but I put the negative 40 here. Everything else, a is 20. That was our first term, and the common difference was negative 6. So if you've forgotten how to get any of these other values, just go back and review 7.1. cleaning this up, we distribute those brackets and all the constants on the left, and we isolate the variable, and we get n equals 11. I got a box around that there, so that that's an important piece of information. We're not done though. Okay, the question said find the sum of the series. Well, n is 11. That's not the answer. The sum is not 11. What we know is n is 11. That means we're looking for, this is an 11 right here. It means we're looking for 11 terms. There are 11 terms in this series. Okay, so we're going to take that answer. That formula goes up. And we sub in 11. Sum of 11 terms, so S11 is negative 110, so a nice boxed up answer here. Therefore, the sum of all the numbers in the given series is negative 110. Example 3. I think this is our last example, so I'm only at 11 minutes here. So as you know, you pause these videos as you need to write everything down, because I'm doing it faster here than I would be on the board because I've already typed up all the steps. Make sure you're hitting pause each time. Example 3. The sum of the first 4 terms of an arithmetic series is negative 8. The sum of the first 5 is 85. Determine the first term and the common difference. Okay, S4 is negative 8. That's from this first sentence here. S5 is 85. That's the sum of the first 5 terms is 85. That's all. That's all we have. Determine the first term and the common difference. Okay, I don't have much information here. So even when I put in the formula, I know I have to use this formula because the question's asking for a sum. There's really nothing I can put it. Well, there's some things I could put in there. How are we going to sub it in the formula? So let's say I took this S4 and I put S4 here. That would mean my n is a 4, so I would have a 4 and a 4. But I still don't know I don't know what well, I do know what I don't know what term 4 is. I know what S4 is. I could put a number there, but so I'm going to have too many unknowns. Even if I tried the 5 instead of the 4, I would have too many unknowns. So here's a new strategy. So just that you understand, S5 means you've taken term 1, you've added term 2, term 3, term 4, term 5. That's what S5 means. You've added up 5 terms. S4 means you've added up 4 terms. That's what the sum is. But what we're going to do here is subtract. So sum 5 minus sum 4 is just, I'm just going to write it like that. It's not sum 3. That's not what it is. It's sum 5 minus sum 4. So T1 minus T1, right? They're going to cancel out. T1 minus T1 is going to be 0. Let me just cross this off right here. Term 1 minus term, my pen's not working. Term 1 minus term 1 becomes 0. Term 2 subtract, so we're subtracting. They're gone, they're gone. Term 4 subtract term 4, they're gone. So we've got term 5 subtract nothing. So term 5 just comes down. So sum 5 minus sum 4 is just term 5. So what does that mean? Why did I do that? Look back up to the information we were given in the question. I know that sum 5 is 85, sum 4 is negative 8, so I now know term 5 is 93. Okay, the question didn't ask for term 5, but it is a piece of information I need so I can go back up to the formula because I didn't have enough information to sub in. So I now know that term 5 is 93. We have a value for S5 and T5. So we're going to use the 5. We're not going to use the S4 anymore. We're just going to stick with the 5s so that we have the same value for n. Back up to the formula. Putting in the 5s everywhere we had an n. But remember, sum 5 is 85, right? That was in the question over here. We know that sum 5 is 85, so I can replace these two. I know what term 5 is because I just worked it out. It's 93, so that gets replaced there. And cross multiplying, or we're multiplying both sides by 2, this 2 gets multiplied up by 85. This is an invisible 1 under here, so when I cross multiply this side up here, nothing happens because it's just 1. And just doing a little bit of algebra, I get a equals negative 59. And I need to box around that because the question asked me for the first term. So I have to make sure that that's clear. What is the first term? Okay, but we're not done because the question also asked for the common difference. We still need to find d, so we need a formula that has a d in it. I can't go back to my sum formula. There's no d there. That's not going to get anything that way. So we go back to our 7.1 formula, subbing in those 5s, and now we know what a is, right? We got a back here. We know that a is negative 59, so I could sub that in. And distributing these terms to d, doing some algebra, I get d equals 38. So that is my second part of the answer. Make sure to have a box around that so that that's clear for me too. Therefore, the first term is negative 59 and the common difference is 38. So just again, make sure your answers are very clear. So that's the video for 7.5. You might need to review 7.1 again if you were struggling with this because you were forgetting about maybe this formula here, how important this one was from 7.1, so maybe you need to go back to 7.1. But if you understand everything and you're ready to go back to do the homework that's listed on your sheet. That's the end.